Hello, my name is Elise Levin-Güracar, and I'm an education researcher at TURC. Today I'll be presenting a paper co-authored by my colleagues, Nuria Jaumot-Pascual, Teresa Lara-Meloy, and Eways, about one of our projects related to math and making. I'll be diving into an individual case study of one of our youth participating in the Amped for Making program. Amped for Making is developed through a collaboration between TURC and the Cesar Chavez Foundation and was based on work partially supported by the National Science Foundation. It's a 2-year after-school program that integrates math and making into semester-long units and implements community-focused values of labor organizer Cesar Chavez. The program ran at 7 public middle schools across California and the United States. Facilitators were trained on both the program norms as well as maker skills, such as how to use a 3D printer and woodworking tools. Many of the 200 youth served were multilingual and Latinx. The main programmatic goal was to engage youth in a blend of design and making for the community, consequential making to enhance and develop youth's agency and positive identity as makers, mathematical doers and users, and community members. For this case study, we aim to address 2 of our research questions. What math content and practices do your youth learn through participation in Amped for Making? And how do youth's agency and identity as makers, mathematical doers, and users and community members change with participation in Amped for Making? While data collection methods used in this include a youth survey, a math learning assessment, interviews with facilitators, weekly facilitator feedback, and object elicitation interviews or focus groups with the youth, this single case study is exclusively based on data of the analysis of object elicitation interviews. Object elicitation is a data collection method that centers the youth interview around an object that the youth made in the program. So they're actually physically holding the object. Since the objects were created by the youth, the object embodies the youth's knowledge, skills, and attitudes, and makes the interviews easier by shifting the focus of attention from the interviewee dyad to the actual object. This type of interview elicits richer information than regular interviews because images and objects facilitate recalling processes and memories in more detail. For this case study, we're going to be focusing on Rose, who participated in Amped for Making as a 7th and 8th grader. She was interviewed in May at the end of each of those school years. In the first year, Amped for Making projects were focused on making for family and community. During that year, Rose made a muffin stuffy to represent her family who likes to bake and a cubby for classroom materials. You can see her in these photos holding the muffin stuffy that she made. That's part of the object elicitation interview, and making cubbies, strengthening the sides with 3D printed connectors. In year 2, the projects focused on the school community, and they made a planter box for the school. You can see from the photos how involved this making process was. Rose used a sander, a saw, a vise, hammer, and nails, all to put together these 2 beautiful planter boxes with her peers. We're going to be talking about how Rose's maker identity and math identity developed through her 2 years of participation in this program. Maker identity includes initiative and intentionality, conceptual understanding, problem solving, and critical thinking, creativity, and self-expression, as well as social and emotional engagement. In her first year, Rose uses her creativity and self-expression to respond to the making prompt of creating a stuffy that embodies something meaningful to her. She shared that she made a muffin because her family likes to bake, and by making this object, she was able to share this fact about herself with her peers. In year 2, Rose spoke a lot more about her collaboration that she actually had in making the objects. In year 1, Rose knew how to sew, but she didn't share that with her peers. She said, "Nobody asked me," when asked if she helped anybody sew. So she's sort of lacking the initiative and collaboration that we see in a strong maker identity. But in year 2, she very clearly works with her 2 peers. Each of them took on distinct roles in the making of the planter boxes. The planter box was also being made for the school community, and Rose had a really clear idea of how making this planter box was contributing and giving back to her school. She thought it would be beautifying and that it would be able to be providing a medicinal plant. She thought that they could plant aloe vera that a student could use if they were sunburned. Rose demonstrated growth in her maker identity in terms of more collaboration and being more able to clearly describe the steps that she took to make a final project. We're also going to think about Rose's math identity. Math identity encompasses a person's self-understanding in the context of doing math, and it's also a cluster of aspirations, interest, engagement, and perceived competence. In the first year, when asked about the math that she did in the program, Rose shook her head and said that no, she didn't do any math. So she really lacks a clear connection between the projects that she's doing and math, and a lack of interest and engagement around math. By year 2, Rose has detailed descriptions of the math content that she used to measure the wood beams and to think about the volume of soil needed to fill the planter. She demonstrates fluency, engagement, and confidence when talking about math, and was very excited and eager to share about the math that she used. Through Amped for Making, Rose had opportunities to engage in consequential math, making beautiful objects for her community and about her community. Rose was able to make connections and develop positive identities in math and making. By the end of the second year, seeing really strong connections between the making that she was doing as part of the program and mathematical concepts. Bringing together math and making in informal learning environments such as the one in Amped for Making supports math skills development and an understanding of the relevance of making skills in terms of being able to make something for your community. Please feel free to contact a member of the team if you have any questions at all about this project. We would love to hear from folks. And we would like to thank the National Science Foundation for partially supporting this work. Of course, any opinions, findings, and conclusions or recommendations expressed here are those of the authors, and they don't necessarily reflect the views of the National Science Foundation. We would like to thank Rose for her participation in the program and in data collection, for being really thoughtful and sharing her insights with the team in the object elicitation interviews. Additionally, we would like to thank Vanessa Galliana, who was a summer intern at Turk through the REU program. She began data analysis for this longitudinal single case study. Thank you.